Hello again, everybody. It's Pete from Hacking Math. I just figured we'd take a look at this tough differential calculus problem. This does look like a tough problem. It gives you a function that you're supposed to differentiate. So that's the function in terms of x, and they don't tell us what p is. But there's a line with a slope of 2.5. That's the way they write it in Europe, I think. And it is tangent to the function at point A, and the x value of the tangent point is -1. They're just asking for the equation of the line. Okay, so as you can see, the algebraic solution is pretty complicated. But all this problem really requires is that we create that function, and then we'll see what p has to be. I'll show you. So obviously we have the x and y axes, and then the function is doing something, I'm not even sure what it's doing. And then at -1, there's a line that's tangent to it at that point, and it goes up. Its slope is 2.5. So it goes, what, up 5 and over 2, that kind of thing. So we just need to know at what point on this function is the slope at -1 equal to 2.5. That way we can find out what the point is just by putting in f of -1. When we find p, we'll find out what p is, and then we'll find out what the y value is. So we'll know that that's -1, maybe it's 7. Then we'll be able to give the equation of the line. We know the line is 2.5x plus something. And the only line that has a slope of 2.5 that goes through -1, 7, for example. All right, we'll be able to figure that out. Okay, let's go to Python. So for this problem, we're going to need the square root. Then we're just going to define the function. There we go, except we don't know what p is. So we're just going to have to find out what p is by trial and error. Now we need a derivative function. Finding the derivative of a curve, what you do is you zoom in on some spot, even closer than we've got here, but even if you zoom in on this, it looks like a straight line. If you zoom in enough on any curve, it's going to look like a straight line. So all we do is we're looking for, this is f of x, then we're just going to take a really tiny step. Like in calculus class, they call it delta x. I don't have a delta on my computer, so we'll just call it dx. All right, and this is x plus dx. And this is going to be f of x plus dx. So if this is a straight line, then the rise is going to be f, the function, the y values, the f of x plus dx minus f of x. And the run is just going to be dx, like a millionth or something like that. That's how we're going to find the derivative at each of these points. We're going to say, start off at 0, p being 0 and p being 1, and so on. Find out for what p is the derivative at -1 equal to 2.5. All right, that should give us our derivative of any function that we can describe in Python terms. Let's see, we should probably test that though. I know the derivative of x squared, for example. It's always twice the x value. So I'm just going to check and make sure. If I print out derivative of g at 5, it should be 10, right? No matter what p is. Let's do that. Yeah, our derivative function works. Now all we have to do is do that for f. And we're going to vary the values for p. It looks to me like p can't be anything from -1. It could be -1, but it can't be anything smaller. We'll start off with 0. We'll just see. From 0 to 20 or something. Print the derivative of f at -1, and then p is going to be our variable. So we'll see, where is it 2.5? We should ask it for the value of x that we're putting into the function. So there we go. At 3, the derivative is 2.5. So we know p is 3. Great. Now all we need to know is when p is 3, what's f of -1? Don't need that anymore. So what, Alt 3? Yeah. And print f of -1 when p is 3. So f of 1 is 6. All right, at -1, f is 6. So we could go to the big board here and just say, look, we've got at -1, the line is, wow, perfect line. At -1, the line y is equal to 2.5x plus some y-intercept is at 6. So what's the y-intercept? I think you can tell it goes up 2.5 for every one it goes over. So, but here it is. 6 is equal to 2.5x. 2.5 times x, which is -1, plus our only unknown. So 6 is equal to minus 2.5 plus b. So b is 6 plus 2.5, which is 8.5. So that line is 2.5x plus 8.5, the line that they called k, which goes through our mystery function. And I used my graphing program in processing that I wrote in my book, Math Adventures with Python, and I graphed the function. So there it is, 9 times the square root, yada, yada, yada. P is 3. And so that's the curve there. I also put the line in there. Let me just show you the curve. I'll comment that out. So that is f. And as you can see, at -1, it looks like it's at 6. Yep. So I added the line to it, to the graph, and the line goes up to 8.5. Not an easy problem to do algebraically, but not so hard to do with Python. So, if this helped you, like and subscribe, and we'll see you in the next one.